Video on C++ tutorials. Today we're going to talk about structures in C++. When we finish talking about arrays, the obvious next step is then looking at data structures that are kind of a combination of various data types. But before that, I'm going to apologize for the high noise of my keyboard in the previous videos. I'll try to be a little lighter on the keys. These new MacBooks, they are kind of funny that way. So the first thing that we are going to talk about is our starting point is integer array. Or any other array for that matter, any primitive data type. So an array is essentially a data structure which allows you to save multiple integers, because this is an integer array, multiple integers in a sequence. In the memory, this is pretty much consecutive memory locations. So when you say an integer array, you can basically save integer type. So 10 elements of the same type, which is an integer type. And the index values, as we know, move like this. So you start at 0, you finish at 10. These are 10 integer memory locations. Now, there are situations in real life where you have to store values which are not integers. So maybe you want a structure which can store a string, a character variable, a couple of integer variables, and a couple of double variables. So in those situations, clearly a simple integer array is not going to work. So this brings us to our topic of today, which is structure. So the definition of a structure is rather simple. All you have to do is you basically say struct, define your structure's name, and so for simplicity we call it a type, and the reason is that any object of this type structure is going to have all of these members. So all of these variables that are defined inside the structure are variables of the structure or members of the structure. And we call this class type because when in code, when you have multiple variables defined, a lot going on, this will remind you that this class type is basically a structure, so it has data members. So it's a little different from a simple integer and so on. So it's just a memory thing. It's just for ease of reading your code. When you do this, what you get in the memory is a set of memory locations which represent the number of bytes required for each. So it's an integer, typically 4 bytes. String depends on what you're storing in the string, another string, and 2 integers right here, and finally a character. So this basically is class type. So all of this information is related to a class. You can see I've filled the memory locations here. Right here, right now, this is just the definition of a structure, which means that there is no memory allocation at this point, unless I assign these values, and that is when the memory is actually allocated. So this is what the memory looks like. Now, remember I said if you need multiple variables, you can use structures. But interestingly, you can create an array of a structure as well. So you can say class type, which is basically the type that you just defined, a class list. This is your array variable name, and I have 3 elements here. This looks like something like this in the memory. So you have combinations of the same data members or same members of the structure repeating over and over again. So as far as this array is concerned, this is 0, this is 1, and this is 1. This is 2, I'm sorry. So each member inside this is referenced with respect to this variable name. So over here, you can say class list 0 dot course ID is right here. Class list 0 dot code is here. Class list 0 dot title is this. And class list 2 dot course ID is this one. So I hope you get an idea of why you would need structures and what structures are all about. Now, so now we're going to write some code to basically bake these concepts in our minds, and let's move. compiler. This is made available by cpp.sh, so a big shout out to the guys who maintain this. This is a really handy way to test out your C++ code. So we're going to start dive into this. We're going to start writing our structure. The structure, the name is, let's say, class type, and for the sake of simplicity and saving a little bit of time, what I'm going to do is I'm going to declare just two variables as members. So I'm going to say course ID, and I'm going to say a character, which is the section. So course ID and section. So these two are the variables. I can now define an object of type class type. So I'm going to say class type, and I'm going to say physics class. Next, assigning values. So let's go ahead and assign values to these the members in this class. So this class basically has this variable, this object has two members, course ID and section. So I can assign them just like this. So class dot course ID and is equal to, let's say, 1 2 3 4, and I'm going to say my physics class dot section equals to A. Okay, and then I'm going to just print whatever I just assigned. So I'm going to say ID is and cout is going to take the other parameter operator. ID is course ID. Physics class dot course ID, and a new line. Next up, section. So just a little formatting at the output so that it looks neat and clean. Physics class dot section, and I just leave it there. So let's run this. This basically should be pretty simple. It prints the ID right here, and it prints the section with it. The idea is obviously not to hard code anything, so we're going to, in the next step, put this in a for loop. But essentially, let me show you how you can declare other variables of the same data type, just like you can do with any of the primitive data types. So let's say math class, and right here you can say math class dot course ID is equal to 4567. Math class dot section is equal to D. Now let's go ahead, and so I'm going to just copy these two. You can tell that I am a Windows user, but I just sometimes use my Mac as well, and this is what happens when I do. So math class instead of physics, math class, and I'm just going to put an extra n line here. Okay, so let's run this. The output should be what we expected: two different objects, two different members per object. Now we can also create a class, an array of this type. So what I'm going to do is I'm just going to remove the second object that we created, just for simplicity, so that you can concentrate on the one object that we have. So I'm going to create an array of two objects, so I can save two information about two different sections about PyClass here. So now this time, instead of hard coding this, I'm going to define I'm going to ask the user to provide values for these variables. So remove the assignment, instead use the cn, remove the assignment, instead use the cn. Similarly, when I'm printing, I would be interested in printing the two sections separately, so not hard coding anything here. I'm just going to put this in a for loop as well. Now, interestingly, this pi class or physics class doesn't really mean anything anymore because this is an array. Physics class, this variable just points to the first memory location in that array, but we don't need that, so we have to explicitly mention which particular item in the array are we talking about, and that is how we do that. Similarly, when you are printing, you need to exactly mention what you are going to print. Okay, so and just for the sake of clarity, I'm going to just print enter ID before this one, and I'm going to say intersection before this one. So and I'm going to put an end line before this one so that it goes to the new line as well. Let's see. Enter ID 1234, section C, ID 3456, section B, and there you go. So I hope this was a useful introduction to structures. We're going to work with structures in later videos, which are more complex. But this basically is a simple way of writing a structure, which is defining a structure and then creating objects of that type. Each object is then accessed, each member in the structure is then accessed with reference to the object, and that's why we call this period right here as a member access operator. Thank you very much for listening. Please hit the like button if you like the video. Thank you very much.